Bismillahirrahmanirrahim. Assalamu alaikum and welcome back to my class. I hope everyone is fine and safe. I expect that all of you have heard the previous video and we can continue with the updated lecture. So, just to remind you that in previous lecture we covered what is present worth or present value and net present worth and net present value, and what is difference between present worth and net present worth. Then we define how we can mm, set several alternatives or formulate alternatives. I explained that we have two types of economic alternatives: uh, mutually exclusive alternatives and independent projects. In case of mutually exclusive alternatives, acceptance of one option or project will lead to rejection of others because all projects are competing against each other and they are serving the same purpose, and one of them would be enough to fulfill our needs. That's why acceptance of one will lead to rejection of others. And in case of independent projects, any number of projects can be selected if they have present worth and net present worth is equal to or greater than zero, subject to availability of funds. Then we discussed cash flow estimates on the basis of revenue estimates and cost estimates, or you can say revenue alternative or cost alternatives. In case of revenue alternatives, we have to consider both revenues and costs. And in case of cost estimates or cost alternative, we'll consider only the cost of purchasing or replacing an asset. Then we studied how to conduct analysis of different projects on the basis of present worth. I explained the process, then we discussed an example, and I left you with a question to solve. I hope you have solved the question. Anyway, I'm going to explain it in this lecture as well. So let's start with explaining the question first. So a university lab is a research contractor to NASA for in-space fuel cell system that are hydrogen and methane based. During lab research, 3 equal service machines need to be evaluated economically. Perform the present worth analysis with the costs shown below. The MARR is 10% per year. So if we focus on the information, we can identify or establish the fact that these are equal service projects or equal life projects. So if you focus on the second sentence, during lab research, 3 equal service machines need to be evaluated economically. Means equal service means they have equal life. And rate of return, our minimum attractive rate of return is 10% per year, and we are given with first cost or initial investment, annual cost or operating expenditures per year, salvage value, and life in terms of years. So we have 3 options: electric, gas, and solar. The initial cost of electric is minus $4,500 and gas is minus $3,500 and solar is minus $6,000. Then operating cost per year is $900, $700, and $50 respectively for electric, gas, and solar. Salvage value is 200, 350, and 100 respectively. And life of all these projects is 8 years. So now what we need to do, we need to calculate net present worth for all these alternatives or options. We need to calculate net present worth for electric, gas, and solar machine. So how we can calculate? First of all, we need to identify which amount is at which year. So if we talk about initial investment or first cost, this is at time 0, already a present amount, so we do not need to make any calculation to convert it into present worth at time 0. We'll consider this initial cost as it is in all cases. Then if we talk about annual cost or operating expenditures per year, we can consider these expenditures as annual series of payments for 8 years, and we need to calculate present worth of annuity by using P over A factor for MARR, which is 10%, and number of years 8. So P over A factor for 10% and 8 years for annual operating cost for all these three machines by using $900, $700, and $50 as annual payment. Then if we talk about salvage value, this is a negative cost, so we will consider it as cash inflow. So we need to convert this future amount at the end of 8th year into present worth at time 0. So we'll use single payment factor, which is P over F factor for 10% and 8 years. So let's go to the solution. Here it is. If we see present worth of electric machine is minus 4,500, that is initial investment at time 0, we'll write it as it is. Then minus 900, these are outflows every year, so we need to calculate present worth of this annual series of payments. So P over A factor for 10% and 8 years plus 200 salvage value at the end of 8th year, we need to convert it at time 0 in present amount. So 200 P over F factor for 10% and 8 years. And the present worth of electric machine is $9,208. This is a negative amount. Then present worth of gas machine minus 3,500 initial investment, 700 annual cost. So P over A factor for 10% and 8 years plus 350 salvage value at the end of 8th year, convert it into present amount by using P over F factor for 10% and 8 years. The resulting amount will be minus $7,071. Finally, we need to calculate present worth of solar machine, which is minus 6,000 initial investment and minus 50 annual operating expenditures multiplied by P over A factor for 10% and 8 years plus $100 salvage value at the end of 8th year, converted at time 0 by using single payment present worth factor for 10% and 8 years. And the resulting amount will be minus 6,220. Now the criteria to select among cost alternatives is the less or minimum negative value. In that case, we have 9,208, 7,071, 6,220. All these are negative values, so we'll select the lowest negative value or less costly option, that is solar one. So in that case, we'll go with solar one. Clear? I hope it will be clear for everyone. Anyway, if you have any questions, feel free to ask. Now, the next topic is present worth of different life alternatives. When we need to use the present worth to compare mutually exclusive alternatives that have different lives, the equal service requirement must be met. Means the present worth of the alternatives must be compared over the same time period or same number of years that must end at the same time to satisfy equal service requirement. So this is necessary since the present worth comparison involves calculating the equivalent present worth of all future cash flows for each alternative. A fair comparison requires that present worth values represent cash flows associated with equal service. And in case of cost alternatives, failure to compare equal service will always favor the shorter-lived mutually exclusive alternatives, even if it is not the more economical choice, because fewer periods of costs are involved. It means in case of cost alternatives, if we are not able to satisfy the equal service requirements, we have to choose the option with short life rather than the option with higher life due to involvement of less cost periods. Further, we can satisfy the equal service requirement by using two methods. One of them is LCM approach, means least common multiple approach, and the second one is known as study period approach. I will explain them later. So let's start with present worth of different life alternatives. So the only condition that we need to satisfy is that we must compare alternatives for equal service, means alternatives must end at the same time. So the two ways to compare equal service are least common multiple of lives, and the second one is specific study period. So if we talk about least common multiples, in that case we need to compare the present worth of alternatives over a period of time equal to the least common multiple of their estimated lives. And in case of study period, we need to compare the present worth of alternatives using a specified study period of n years. This approach doesn't necessarily consider the useful life of an alternative. That's why the study period method is also known as planning horizon. It means that in case of study period, we need to define a study period. Let's say the useful life of an asset or a machine is 10 years, but the study period is only 3 years or 5 years. So our analysis will be based on the time period that is considered as study period. That can be 3 years or 5 years rather than the useful life that is 10 years. So we'll make calculations on the basis of 3 or 5 years, that is study period, rather than the total useful life of that asset. So let's continue with the explanation of least common multiple of lives method. So in case you are given a situation where you have two options with different life, so you can use LCM rather than study period unless stated. If you are explicitly given the instruction that you need to use specific study period, then you need to use it. Otherwise, you can use least common multiple of lives. So, for any of the approaches, we need to calculate present worth using minimum attractive rate of return to select the project. The LCM approach makes the cash flow estimates extended to the same period as required. For example, if we have two different life projects, the life of one project is 3 years and the other project is 4 years. Now what we need to take, we need to take LCM of the life of both projects. So 3 and 4, in that case the least common multiple will be 12. So we'll consider the life of both projects equal to 12 years, and we'll make calculations on the basis of 12 years time period. So in that case, the first cost of an alternative is reinvested at the beginning of each life cycle. Means if machine A has life of 3 years and machine B has life of 4 years. So in case of machine A, we need to reinvest initial amount after every three years, and in case of machine B, we need to reinvest that amount after every 4 years. And then the estimated salvage value is accounted for at the end of each life cycle when calculating present value over the LCM period. Similarly, as we done for the initial investment that we reinvested, and in case of salvage value, we need to take back that amount at the end of each life cycle. These things will be clear once we'll go through several examples. So here are a few assumptions of LCM approach. First of all, services provided is needed over the LCM or more years. Means you do not need to consider the life of asset. The calculations should be based on least common multiple time period. Then selected alternatives can be repeated over each life cycle of the LCM in the same manner. Means at the end of each life cycle, you need to reinvest initial investment, and you need to withdraw the salvage value as well. So cash flow estimates are the same for each life cycle. For example, change in exact occurred with the inflation or deflation rate. Until unless stated, you do not need to consider inflation or deflation. So here is an example for different life alternatives. We need to compare the machines below using present worth analysis at a rate of interest 10% per year. So we have two machines, machine A and machine B. Initial cost of machine A is $20,000, B is $30,000, and annual operating cost is $9,000 and $7,000 respectively. Then the salvage value is $4,000 and $6,000 respectively. The life of machine A is 3 years and machine B is 6 years. So the life of both machines is different. That's why we need to calculate least common multiple. So in that case, least common multiple will be 6 years. So in that case, we'll focus on a time period of 6 years. So in 6 years, we can have 2 cycles of 3 years. Means when the one cycle will end, we'll repurchase machine A, and at the end of first cycle, we'll also consider the salvage value as well. So let's start with calculating present worth of machine A. So present worth of machine A minus 20,000 initial investment at time 0, that will come as it is. Then 9,000 are annual expenditures every year for coming 3 years, and this will be the same for 4, 5 and 6 years. Now here we have two options. So we can consider it as an annual series of payments for 6 years, and we can consider two annual series of payments, each consisting of 3 years. So here I have considered it as an annual series of 6 years and converted it into present amount by using P over A factor for 10% and 6 years. Then at the end of third year, we have to reinvest 20,000, that is initial investment for second cycle. But at the end of third year, we have a salvage value of $4,000. Now again, two approaches can be used. First, use 20,000 as initial investment and minus 4,000 as salvage value, or you can take the difference of 20,000 and 4,000 and consider 16,000 at the end of third year. That is our initial investment at the end of third year. So we need to take it back to time 0 by using P over F factor for 10% and 3 years. So once we have used P over F factor for 10% and 3 years with 16,000, we have considered the impact of both initial investment and salvage value as well. Then finally we'll have 4,000 salvage value at the end of 6 time period. That is the salvage value, the asset we repurchased at the end of third year. But we need to convert this amount in present worth at time 0. So from time 6 to time 0, we have 6 time period. That's why we'll use P over F factor for 10% and 6 years. After making all these calculations, the present worth of machine A will be minus 68,961. Now we can calculate the present worth of machine B. Minus 30,000 initial investment as it is, and 7,000 annual series of payments, convert it into present worth by using P over A factor for 10% and 6 years. Then the salvage value of 6,000 at the end of 6 years. This is a single amount. We have to convert it into present amount by using P over F factor for 10% and 6 years. The amount is minus 57,100. Now both are cost alternatives, and we have to accept the less negative value, that is minus 57,100. So the project B should be selected rather than project A. Clear? I hope so. Then present worth evaluation using a study period. So a study period analysis is necessary if the first assumption about the length of time The alternatives are needed cannot be made means the service provided will be needed over the entire LCM years or more. Where we cannot calculate the LCM, our calculations on the basis of LCM are unrealistic. In that case, we will use study period. For example, if we have two projects, the life of one project is 5 years and other project is 9 years. So the LCM will be 45 years. In that case, what we need to do, we need to repeat investment of first machine for 9 cycles of 5 years to have comparison. So in that case, the calculations should be based on study period rather than the LCM period. So for the study period approach, a time horizon is chosen over which the economic analysis is conducted. And only those cash flows which occur during that time period are considered relevant to the analysis. So any cash flows occurring during the study period will be considered for analysis, and other cash flows that are occurring after the study period has ended will not be considered. Similarly, an estimated market value at the end of study period must be made to consider the salvage value. The time horizon chosen might be relatively short, especially when short-term business goals are very important. So the study period approach is often used in replacement analysis, means when you have to replace assets, so you will consider the study period approach rather than LCM approach. For example, the life of an asset is 5 years and you want to purchase it, you want to replace it after 4 years or 3 years. In that case, study period is more relevant rather than LCM period. So here are the assumptions. Once a study period is specified, all cash flows after this time are ignored. As I explained earlier, salvage value is the estimated market value at the end of study period. As I told earlier that we have to estimate the market value at the end of study period, that is salvage value. So short study periods are often defined by management when business goals are short term. So study periods are commonly used in equipment replacement analysis before they become obsolete. So here is an example. We have to compare the alternatives below using present worth analysis at a rate of interest 10% per year and a 3-year study period. So this is the same example that we discussed earlier, but here we'll use study period rather than LCM. So the study period here is 3 years, and the initial cost of both machine is $20,000 and $30,000 respectively. Annual operating expenditures are $9,000 and $7,000. Here we have salvage value of machine A at the end of third year, that is 4,000, and salvage value of machine B at the end of third year and sixth year as well. So salvage value at the end of sixth year is $6,000 and at the end of third year is $10,000. So when we are focusing on study period, that is 3 years, so we'll use the salvage value at the end of third year rather than at the end of sixth year. So let's start solving problem. So here we have a study period of 3 years, so we need to disregard or ignore all cash flows after 3 years. Present worth of machine A minus 20,000 initial investment as it is, then minus 9,000 annual operating expenditures for 3 years. So we need to convert it into present amount by using P over A factor for 10% and 3 years. Then we have to deal with salvage value at the end of third year, which is 4,000 P over F factor for 10% and 3 years. So the present worth of machine A will be minus $39,376. Now we can calculate present worth of machine B. So minus 30,000 initial investment as it is, 7,000 annual expenditures for 3 years, convert it into present amount by using P over A factor for 10% and 3 years, that is study period. So make it clear that here we need to use study period rather than life of the machine. That is 10% and 3 years. And the salvage value at the end of third year is $10,000. So P over F factor for 10% and 3 years with 10,000. The resulting amount is minus $39,895, which is slightly or marginally higher than the present worth of machine A. Anyway, the selection criteria is same. We have to select the machine with less negative value or less cost, which is machine A. So we'll select machine A. So if you remember in previous case when we were following the LCM approach, we selected machine B. Here we are going to select machine A. So the result has changed with the difference of method here. Keep in mind, bear in mind that both methods, study period or LCM method, may provide different results at times. Then here is another question. Let's discuss it as well. So Midwest Power and Light operates 14 coal-fired power plants in several states. Around the United States, the company recently settled a lawsuit by agreeing to pay $60 million in mitigation costs related to acid rain. The settlement included $21 million to reduce emissions from barges and trucks in the Ohio River Valley, $24 million for projects to conserve energy and produce alternative energy, $3 million for Bay, $2 million for National Park, and $10 million to acquire ecologically sensitive lands. Now the question of how to distribute the money over time has been posed. They have two plans. Plan A involves spending $5 million now and the remaining $55 million equally over a 10-year period. That is $5.5 million in each of years 1 through 10. Then Plan B requires expenditures of $5 million now and $25 million 2 years from now and $30 million from 7 years from now. We need to determine which plan is more economical on the basis of a present worth analysis over a 10-year period at an interest rate of 10% per year. Now we have two plans. In Plan A, 5 million now and 55 million equally over 10 years, $5.5 million per year. And Plan B, 5 million now, 25 million after 2 years and 30 million after 7 years. So we need to calculate present worth of both plans and compare it to reach a conclusion which plan is suitable, where rate of interest is 10% per year. Let's start. So present worth of a 5 million at time 0, that will come at as it is, and 5.5 million every year for coming 10 years. So we can consider it as annual series of payments, and we can convert it into present worth by using P over A factor for 10% and 10 years. So the P over A factor for 10% and 10 years is 6.1446. So the present worth of Plan A will be minus $38.795 million. Similarly, we can calculate present worth of project B, minus 5 million at time 0, minus 25 million at the end of second year. So this is a single amount we'll need to convert into present amount at time 0 by using P over F factor for 10% and 2 years. Then for coming at the end of 7th year, we have 30 million. So this is also a single amount and we need to convert it to time 0. So we'll use P over F factor for 10% and 7 years. Factor values are 0.8264 and 0.5132 respectively. Then the present worth of project B will be minus $41.056 million. So let's compare the present worths of both option A and option B. So these are outflows. We need to compare cost. In that case, we'll select an option with less cost, that is less negative value, which is minus 38.795 million in that case. So the plan A should be implemented in that case. Is that clear for everyone? I expect that you understood the lecture. And anyway, if you have any questions, feel free to write. I will try to address them as soon as possible. That's all for today. See you in next lecture. Bye bye. Allah Hafiz.